This video is about 3-7, multiplying 2-digit by 2-digit numbers. Just like in 3-6, we could use either the algorithm or partial products to solve 2-digit by 2-digit multiplication problems. Let's use the algorithm first, and we're going to solve the problem 72 times 16. You need to multiply each of the bottom numbers by each of the top numbers. So first I'm going to multiply 6 times 2, which is 12. And then I'll multiply 6 times 7, which is 42, plus 1 is 43. Now I'm going to move over and multiply this 1 by each of the top numbers. However, since that 1 is in the tens place, I need to put a 0 in the ones place to show that this isn't just a 1, it's a 10. So that 0 shows us that that's a 10 and shows that we're moving over to the left one place value spot. Now I'll multiply my 1 by this 2, so 1 times 2 is 2, and I'll multiply 1 by 7. 1 times 7 is 7. And I'll add up my numbers, 2, 5, and 11, to get my final answer of 1,152. I like to draw these lines up here to show the numbers I'm multiplying because it can help you check your work at the end. You should end up with something that looks like a bow tie. So I call that the bow tie method. You get to check your work pretty easily by making sure that you multiplied each of these bottom numbers by each of the top numbers if you end up with a bow tie. We can also use the partial products method. So if I were doing the same problem, 72 times 16, I need to first write down all the facts that I'm going to do. I need to multiply each of the bottom numbers by each of the top numbers. So I'll have to multiply by 6 by the 2 and 6 by 70, since this 7 is in the tens place. This 1 is in the tens place, so it's really a 10. That's probably the trickiest part about partial products with two-digit numbers, is remembering the value of the numbers. I'll multiply the 10 by the 2 on the top and by 70 on the top. So a way to check that you have all the problems is that your ones digit number should appear twice, your tens digit number should appear twice, and each of your top numbers should appear twice. So there's 2 2s and 2 70s. So now I'm good to go. 2 times 6 is 12. 6 times 7 is 42 with a 0 at the end. 10 times 2 is 20. And 10 times 70 is 700. Now I add these up as my final step. I'll get 2 in the ones place. 2 plus 2 plus 1 is 5. And 4 plus 7 is 11. So again, I still get the same answer of 1,152 using partial products. I'm going to show you the next problem with each of the two ways side by side. So the problem that we're going to do is 83 times 47. On the left, I'll show you how to do that with the algorithm, and on the right, I'll show you with partial products. So when I'm doing the algorithm, I'm going to stack them up and begin multiplying with the bottom number in the ones place, so the 7. 7 times 3 is 21, I'll carry my 2. 7 times 8 is 56 plus 2 is 58. I'm done with my 7, and to show that this 4 is really a 40, I need to put a 0 here. 4 times 3 is 12, so I'll put my 2 here and carry my 1. 4 times 8 is 32, plus 1 is 33. Now I can add these two parts. 1 plus 0 is 1, 8 plus 2 is 10, 5 plus 3 plus 1 is 9, and I'll bring down my 3. So I get my final answer of 3,901. On the right-hand side, I will do it using partial products. I'm going to stack my numbers one on top of the other, and on the right-hand side, I'll write out the 4 problems I need to do. 7 times 3, 7 times 80. I also need to multiply my 40 by 3 and 40 times 80. 7 times 3 is 21. 7 times 80 is 560. 40 times 3 is 120. 4 times 8 is 32 with 2 zeros at the end, which is 3,200. Now I'll add them up. So I'm going to get 10 here. 5 plus 1 plus 1 is 7, plus 2 is 9, and I'll bring down my 3. So again, I got the same answer of 3,901. I want you to try the problem 72 times 51 using either partial products or the algorithm. Good luck!